Heinemann Higher, graphs of functions, exercise 3p, number 7, another former higher. What's it this time? The sketch shows the graph of y equals f of x, right, for this domain, just going from negative 2 to 4. That's all that exists of it. There's another function, g of x, which has got this line, x equals 4, it's an axis of symmetry, and it says g of x is the same as f of x, just from negative 2 to 4. So what would g of x look like all the way from negative 2 to 10? Well, if that's an axis of symmetry for g of x, then it must be the same on both sides of it. So that means that the graph should look like this. And that does then take it from negative 2 all the way to 10. There's a distance of 6. Another 6 on that side, that must be 10. So that's the picture of the graph, like this. Where all those numbers are going to stay the same. So I've got negative 2, 0. That's going to be 2. The top was at 4. So that's going to be at 6. The bottom is going to be 8. And then that part's going to be 10. Going from negative 3 there to 3 there. That would be the graph of that then. B, y equals negative 2g of x. Well, that was g of x going from negative 2 to 10. But you've only to do it from 0 to 8. And it has to be twice the answers you've got, so that's 6 and negative 6, only upside down. So it's this graph turned upside down. So it should look like this, where you've got that point was originally at negative 3, it's going to stay in the same place, still at 0, well it's going to be now up at 6. This point, also this point here was originally 2 at 0, it'll have to stay 2 at 0, no change to the x, and double 0 is still 0. The point at 4 had values 3, negative 2 times it means the point at 4 has now got value negative 6. The point at 6 is still at 0, and then the point at the end here, which was at 8, is now going to be still at 8 obviously, but instead of negative 3, it'll be negative 2 times it, which is 6. So that would be the graph then for part B.